let's quickly see what is included in the solar water heating system. See, my pointer is helping me to unpack here. Okay, so the first big box, this is the solar tank. So this is where the water will be stored in. And if you come a little bit closer, you'll see there's holes in here. So in essence, there's sort of three elements that makes up the solar heater. The first element obviously is the tank, and then we've got solar collectors. The collectors is actually going to fit into these holes. This is a direct system, so the heat that we collect from the collectors will directly heat the water. As I said, I will later during the series I'll explain the difference between different types, but a direct low pressure system is the cheapest and easiest to install, so that's why we begin with it. Okay, so first the tank. Next box. These tubes will make up the collector. They basically vacuum tubes. There's actually two boxes of these. I'm not going to open the other one. Okay, next box. And there's our stand. The stand will actually hold the collector tubes, and on top of the stand the tank will fit. Okay. Because this is a low pressure system, we can't connect it directly to the water feed because the pressure is too hot. So we've got another little tank here which basically works the same as the bowl of your toilet. So what's going to happen, there's a float inside here. So as water comes in, this will fill up. As soon as it's filled, it will stop the water flowing on out of here or into here. And at the bottom it will feed the big tank. So the big tank is not connected directly to the water mains. It's basically fed by gravity. So we can also say a low pressure system is a gravity feed system. So that's the components that's necessary to do the physical installation. Neatly packed in a bunch of boxes. They're not very heavy. Fairly easy to carry. I could carry each one of these boxes on my own. Let's quickly have a look at some theory on the board before we start going onto the roof and seeing where we're going to fit it. As I said, it's a direct system. Direct basically means the sun's rays heats the water itself. An indirect system will use a heating agent like coal or something like that, which then will be transferred to some element which in turn will heat the water. It's a passive system, so basically what we do is we use the principle of convection. So as you all know, anything that is hot rises and anything that's cold settles. So we use that principle to basically create movement of the water through the system. And then lastly, it's a low pressure system, so that means we can't connect it directly to the water mains. So the input into the system from the water mains is cold water, and that goes to a valve. That valve will fill this small little feeder tank up to a specific level, and then the valve will close. this water, because of gravity, will then, cold water will flow into the large tank and actually fill up the tank. Now, the collectors that we've installed is basically hollow tubes. And what happens is the water will then flow into the tube and start filling up from the bottom. But as the sun heats up the water in the collector, that warm water will then rise and collect in the top part of the tank. And as we use water, so warm water to the tap, new cold water will come in, and that cold water will settle at the bottom of the tank and fall into the collectors. Now, the beauty of a passive system is that we basically use this principle of heat and cold, hot things rising and cold things settling, to basically create the circulation. So we don't need a pump or anything to move the water around. So in essence, if you look at the tank as a if you cut through the tank, the water will fall, move in to the collector. The sun's rays will heat up the collector, so that side of the collector will be warmer. Okay, so warm water will be created, and that goes to the top of the tank until eventually everything is warm. So what happens if there's no sun? Well, obviously the stuff at the bottom will become colder and the stuff at the top will stay warm. So the warm water will still be contained in the tank that is insulated. So this is sort of in between the inside and the outside of the tank. There's insulation that makes sure that we don't lose heat. So that's the one thing. If there's no more sun, even if the collector actually gets cold, the hot water is on the top, the cold water is at the bottom. There's no reason for this cold water to rise. So the cold water will stay where it is. I don't know if you've seen when we installed the collectors that the inside of the tube has got a blue purplish color. It's specifically coated in a specific substance that helps the collector to absorb heat from the sun. The last thing that you need to bear in mind is that between the inside of the collector and the outside of the collector there's a vacuum. Remember we said that there's a nip at the bottom and we actually pinched one of those, so we've lost the vacuum in one of those tubes. That vacuum basically works like a thermal flask. So because there's nothing in between, there's nothing that can transfer the cold to the warmer water inside. Remember, what actually came in and heated up the water was not heat, it was photons. And the photons then was converted into heat by this coating on the inside. So if there's nothing in between here, when the sun's rays isn't there, there's nothing that can take the heat and transmit it to the outside of the collector. So that's the basic principle and theory behind a thermosyphon direct water heating system. Two things that I haven't said, you'll see there's two pipes here. There's a pipe that goes up there and there's a pipe that goes up there. As the water in the tank basically heats, it creates pressure. This is a low pressure system, so that pressure needs to go somewhere. Now the sun can actually heat this water so much that it boils. and create steam. So there needs to be some place where that water can go. As long as this pipe is higher than the intake of the system, it's fine, because this water at that specific level will basically remain at that level. If there's pressure from inside, it's got somewhere to go, and same here. You can actually push out those pipes. Okay, cool.